Oh, oh, sorry. So rate of change and slope from tables and graphs. So I glued this in first. So just glue that in, and then you can pause it, and we will start talking about it. Okay, so notice this is talking about the skateboarder's performance. Here's our time, here's our distance. Notice time and distance. So what we are going to be doing, since we were talking about tables, is we need to actually pull the values off of the table. So this point right here, if I look at this point right here, notice 0 isn't listed, but this is actually 0 seconds and 0 feet. So this first point, notice it's on the line with 0 and it's at 1. So the time is 0 for the first point, and then the distance is 1. Okay, go until you find the next point, which is right here. So the time would be 2, and the distance would be 4. So 2, distance of 4. Then we have this one, which is at 4, 7. 4 seconds, 7 feet. The next point is at 6 seconds, and at 7 feet again. This one is at 8 seconds and 7 feet again. And then the last one, notice there is no number here, so after 9 would be 10, and it is also at 7. Okay, so that would be our table. Now you've been looking at rate of change with Terrence, more of, like, and this is the skateboarder Terrence, more of he's moving away, he's moving towards, and then the elevators, it was starting to get into rate of change. So if we look at this, we have been looking at it and saying, okay, it is changing. So it's changing from 1 to 4. So that's 1, 2, 3. So 3 feet in 2 seconds. So we could say 3 feet per 2 seconds. Well, you don't ever hear somebody say, I went 75 miles in 2 hours. You would find out what their actual rate is. So what you're going to be doing for these is you're going to divide them. And I forgot my calculator, so let me go grab it real quick. Sorry, and then my battery's low, so it might die on me. But, so I'm going to do 3 feet per 2 seconds. So I'm going to do 3 divided by 2. So it's actually going 1.5 foot per second. So, and you can look at that and you can see, okay, well, if we look at 1 second, it went up 1.5 feet because it's halfway between 2 and 3. So it went up 1.5 feet. Okay, so now let's look at that over here on the table. So from 1 to 4, I want you to think about how much did that go up? From 1 to 4, it changed by 3. Notice it was going up, so you would put a positive 3. So that's 3 feet. Notice it's the same thing here. And then from 0 to 2, it goes up 2 seconds. So then again, you could do 3 feet in 2 seconds. Well, if I want to find out how much it's going per second, I don't want 3 per 2. I would want to divide those. 3 divided by 2 is 1.5. Remember, that's a fraction line, which also is the same thing as dividing. So 3 divided by 2 is 1.5. Okay, let's do the next set of points. So let's see, we're going from this point to this point, so it's up 1, 2, 3 again, and then it's over 1, 2. So it moved 3 feet in 2 seconds. So 3 feet in 2 seconds. Again, that's 1.5 feet per second. So then I'm going to do this over here. 2 to 4 changes 2. Sorry. And then from 4 to 7 changes 3 again. Okay. So notice on this line, it was a constant rate. These are constant rates. Means it is a linear, it's linear. So if it has a constant rate, notice that means it's going to keep going up and over the same amount each time. So if it went up another 3 and over 2, it would still be a straight line because it would continue that pattern. Okay, now let's look at the next set. This one, notice, changed 0. It went up 0, and it went over 2 seconds. So notice 2 seconds. From 4 to 6, that changes 2 seconds. From 7 to 7, that changed 0. So 4 over 6, 4 feet. Oh, sorry, not. Oh, man. Sorry, you're going to have to borrow whiteout if you wrote that before I realized I was wrong. So it would be 0 feet in 2 seconds. So 0 divided by 2 would be 0 feet per second. And then I'm just going to continue that. It's 0, 0, 2, and 2. So all of those are moving 0 feet per second. Okay, something else that we need to talk about on this line is this point right here. That point we've been calling the starting value. So it's called the starting value. Sorry. If you look at your vocabulary, this is actually called initial value. So initial value is also the starting value, or you can look at it as or at 0 seconds. What is the distance or y value? So that's your vocabulary word. So initial value is telling you where it started. Initial is starting. Okay, notice these little lines right here. Those are, oh goodness.